all, my name is Dom, and in this video we will build a RAG application for chatting with YouTube videos. It will work in a way that you paste a YouTube URL to the chat and then you can literally ask any questions about it, like summarize me the video, give me key moments, or even like generate me a strategy for my use case based on the knowledge in video. And of course, it's going to be a continuous chat. And for this tutorial, you don't need to have any machine learning AI knowledge whatsoever. You should definitely have some JavaScript knowledge, but that's about it. If you're a web developer, full stack developer, or even a backend developer, this tutorial will be good. Let me just quickly show the demo of the app. So as you can see, here we have a YouTube video, we paste it here, and then we process that YouTube video for AI chat. And actually it is pretty fast, so I'm not fast forwarding this. You can see it's already done. And now I can ask, for example, summarize me this video. So I'm not fast forwarding anything. This is in real time. It's pretty fast. We can of course continue the chat. Does he recommend Supabase or not? And I just want to say that this is not a front-end tutorial. That's why this chat, it doesn't look anything special. It's not like super gorgeous new modern design. We want to focus more on the RAG, on the backend, on that AI pipeline, how everything works. And here on the front end, well, we just want to see some app, right? For the technologies for this tutorial, we will be using for front end React and Vite. For backend, we will be using Supabase and Postgres. There we will be storing the data, for example, like chat messages, but also in Postgres, because in Postgres you can store vector data, so it can behave like a vector database. We will be storing our YouTube videos. And finally, we will have a node.js app, something like a service for processing YouTube videos and storing them in a vector database, and then later retrieving parts that are necessary so that we can answer the question. We'll also use LangChain to build that RAG pipeline. LangChain is an amazing framework that helps a lot with building, well, anything for AI and LLMs. And the coolest thing is, once we build that pipeline and established AI chat with YouTube videos, in this case we will also use OpenAI, so we will use models like GPT-4o and embedding models like text embedding 3 large. The coolest thing is that you can then easily add other file types. You can add documents, audio, video, PowerPoint, whatsoever. There are so many things you can easily add in LangChain. And also what's great is that you can easily switch those models. So once you have that whole pipeline, sometimes you can add a new model literally in 1 minute. And how does everything work? Initially, we have a YouTube URL. Then we grab a transcript from it and we store it in a vector database. And that's the first part. We're storing the document. Based on the query, we get relevant parts from that document and then we pass it to the LLM so that we get the answer. And the question you might have is, why cannot we just pass the entire video to the LLM? Why do we need to have this retrieval stage where we only get relevant part? There are many reasons for that. And the first one is that context is limited. You cannot just pass infinite amount of data to LLMs. So you need to grab only relevant parts. Let's say you have a 5-hour-long video and you ask a query and you actually only need first 5 minutes to answer it. Well, then those smart algorithms will pick only those first 5 minutes from the transcript and pass it to the LLM. Besides just limited context, the more data you pass to the LLM, the performance decreases. But even if we have unlimited context and even if performance is not a problem, everything works perfectly, well, it would be extraordinarily expensive, because when you use LLM models, you pay per input and output. And imagine that with every single question, you also need to pass an entire transcript. That would just be extraordinarily expensive. In continuation to those answers, LLMs are stateless. That means that they don't remember your previous question. The only thing why things like ChatGPT or Second Brain work as a conversation is because you smartly pass the conversation history to the LLM too, and then they can continue it. But otherwise, in this case, we would literally need to pass an entire transcript every single time with every question. It would be slow and it would be extraordinarily expensive, and it probably wouldn't even work for longer videos or for multiple videos. Let's now proceed with storing the document. We want to grab the transcript from a YouTube URL and store it in a vector database, along with some other details that are necessary for the chat to work. First, let's initialize Supabase. If you don't already have an account, then just create an account, create a free project, and let's just create a new project. You then have some data needed to communicate with Supabase. So you have your project URL, it is here. Then you have your public anon key, which is safe to use in browsers. And then you have your service role key, which is secret. And anyone with your service role key will be able to do basically anything with your project. So make sure that it is safe in environment variables on backend. Don't pass it to the frontend. And now when we have Supabase, we will add things inside as we need them. Basically, we have one database function we want to call later that will be needed for matching documents, and a couple of tables, vector database table and a few more others for storing chat details. This is that node project, and what we need to do first, we want to initialize the Supabase client, then initialize the embeddings and vector store. Then we will grab the YouTube video, the transcript from the URL. Then we will add metadata to documents, and then we will add documents to the vector store. You see documents here, and we handle videos. The reason for that is because document is quite commonly used in this LLM context. And as I said, later you will be able to store anything there, whether that's music or PowerPoint or PDF, video, whatever. And one name for that is document. That's why when I say we're storing documents, we're retrieving documents, we're actually storing and retrieving, that YouTube transcript. I also have some code for the basic Node app here. It is TypeScript, although I don't use any build tools, so I need to import with JS. I also just hard code API keys here. I don't use those hidden .env files. Because of simplicity, I wanted to use all these things, but then I was like, this tutorial will be way too long, and I want to focus on rag here, and this is not no tutorial. So use common sense when you're building things and use your best practices, but I just don't want to repeat them. The tutorial will be way too long and will focus on too many things that are not important in this context. As I said, it's a simple app, so we have index, where we just import this app. As I said, unfortunately, we need to import JS, even though it's TypeScript. Then here we use this express to parse JSON request bodies. We need to configure cores, and then we're just exporting defaulted app. Then we have our routes. We want to store the document. Later we will add the one for querying the document, and we have this empty service. Let's first add this route to our app. So how it works: store document route, and it's not this, it's actually store document route, but with importing it from store document routes. Route here, and it is like this. Perfection. Let's now go to store document, our service, and let's just return like just OK, true, to test if everything is actually working. For that I'm using this Echo API, which is kind of like Postman, but you can use it in VS Code, which is cool. So our app, it's running on HTTP localhost 8080, and we're calling store document. So now if we send this, we'll get OK, true. Perfect. So that means it works. Let's now continue. we want to initialize Supabase client. But let's just put everything in try, catch, error, we console.error, and then we just return OK, false. I usually use autocomplete. It's cursor, it's amazing, but for this tutorial it will just annoy us. So that's why I'm doing everything manually, like we're in the Stone Age. First, we're gonna initialize Supabase client. So we do Supabase is create Supabase client. For create Supabase client, I'm using a super simple helper that I made. You only need to install Supabase.js, and then you import create client, and you just need to pass Supabase URL and Supabase service role key. So it's that hidden key. They are available in Supabase if you go to project settings, data API. Here's the URL. Let's copy it. And service role key is here. It's hidden, so I'm not gonna reveal it because this is a super hidden, amazing project that I will use. I'm just joking. I will delete it anyway. But yeah, you reveal this code and then paste it there. Again, usually you should not keep those things in code, but this is just a tutorial, so I'm putting it there. But you just create a .env file. And now, after we have this super hidden key for this super amazing project, we need to initialize the embeddings. But before, quickly, what are embeddings? As I said, we are using vector database here. We're not just storing text from a YouTube transcript and using something like regular text search. That simply would not perform well. Embeddings are a bit different because we use smart embedding models like text embedding free large from OpenAI. You don't need to know a lot about it, but basically what they do, they have some text and then they split the text and convert it into vectors. And then let's imagine you have one sentence which is saying, I am Dom and I am the founder of Second Brain. Doesn't matter. That sentence will be converted into like a really big vector. I don't know, multi-dimensional vector. I don't know how many dimensions it has. A lot of dimensions. And then later, if we want to retrieve relevant parts based on that, let's say who is the founder, and then those embedding models will be able to smartly find the parts that we need. And of course, it's not only by keyword. So we can say director, we can say founder, we can say CEO. Those smart models would catch all of those things. Vectors, again, because AI, it's all about vectors, it's all about GPUs. GPUs are made to work fast with vectors. AI, everything is just for vectors, and that's why we need to store everything in a vector database. Again, regular text wouldn't work here. It would just be really not performant, and even if you manage to make it performant, it would just be super expensive. How do we do it? So we do const embeddings, OpenAI embeddings. I think it's something like that. And we need to import it here. We need to pass model, and that's text, embedding, free, large, and then we need to pass API key, yes. So that's also like super hidden in my code. And you of course need to install this LangChain OpenAI package. I'm not gonna install it for you. As I said, there are just so many things that I don't want to focus on them. It's gonna be too much. So every time you need to install something, I will tell you. You just install this LangChain OpenAI. And this is just initialization of the model. We will use it later. Now we need to initialize the vector store. So that is the place where we will be storing those embedded documents, i.e. our embedded transcript. Vector representation of the transcript. That's nice. So we have const vector store is new Supabase vector store. We need to import it. And here you just need to install LangChain community package. And then what do we pass here? So first we pass embeddings. So this is this module that we initialized. Second, we need to pass the client, which is Supabase, which will connect this RAG service to actual Supabase project. Then we need a table name, and table name will be embedded documents. And we also need query name, and that's gonna be match documents. Table name, as I said, we will be storing those transcripts in our vector database. And query name, we need to somehow know which rows to grab from that table of embedded documents. Because imagine in embedded documents, you have thousands of YouTube transcripts and they're all connected to different users, different videos, whatsoever. Our match documents function will be grabbing only the ones that are actually relevant for our query, but not just query, but also for the video itself and for the user. And you can of course put more filter here. We'll come to that later. First, now we will go to Supabase and we will create that embedded documents table. But before creating a new table, we actually need to enable pgvector extension for our Postgres database, and that actually enables us to store vector data in a database. So we go to database, extensions, and we do vector, and we just enable it. And now we can actually create our new table. The name is going to be embedded documents. Then we have some types. We have ID. I don't know why they suggest integer here. I prefer UUID, which is also a primary key. We have created at. We then have some content. Sorry, not context, but content, which is text. We have some metadata, which is JSONB. We have the embedding itself, so this is the vector, and this is vector. Then we have document ID, which is UUID. Where are you? We need that so that we have indexes, that it works faster, and that we can also filter it by it. Because, as I said, document will be, in this case, a YouTube video, and then every YouTube video will be a certain document. So let's say we upload video 1, it has certain document ID. And then later when we query it, we will pass the document ID so that we know, we're chatting with that video. And that also allows us to chat with multiple videos, because we can just pass an array of documents. Let's say we want to speak with 3 different videos. We just pass 3 different document IDs. And then we know, okay, the query will only be connected to those 3 documents. We will not have a default value here, but we will generate that from the metadata, which we will pass when we will store the document. I think it's all good for now. Now we need to grab the YouTube video, and we will use LangChain's YouTube loader for that. Let's init the loader. Const loader is new YouTube loader, and we are creating from URL. Which URL? We'll grab it from the request moments later, and we also want video info like title, description, and everything we can grab. And URL we are grabbing here. So URL from request.body. Okay, we have a problem here. Yeah, we don't need this new. And okay, so far this was just initialization, but now let's actually do something. So we want to call the loader. Await loader.load. And now we can console.log those docs. And now when we have it, let's actually test this immediately so that we see what we have. So we again have HTTP localhost 8080, and we have store document. The only thing we need to pass URL in the body, so let's just pass it as raw JSON. So we have URL and we have this. And now if we send it, something is actually happening. It takes a bit longer because we're actually loading it. So we have OK, true. And if we go to our console, we can see here, so we loaded it. This is our server. And you see document, page content. This is our transcript. So you see title, Supabase, honest review after building 3 startups, tech wisdom, view count, description, blah, blah, blah. Everything is here. This is cool. So it works. Let's go on to the next step. But step that I forgot here is actually splitting the document into smaller chunks, because vector databases work better with smaller chunks, not if you just put like a massive transcript here and you see this is just like one massive transcript. So let's say splitting docs into smaller chunks. And for that we're using recursive character text splitter from LangChain text splitter, so make sure to install that. Let's initialize our text splitter, and that's new recursive character text splitter. We have chunk size, let's put it to 1000, and chunk overlap, let's put it to 200. These parameters, they're not strictly defined, and some are better for other purposes, blah blah. This is something that should work with everything. I use these parameters and they work well with me, but you can experiment with different chunk sizes and chunk overlaps so that you see how it works for you. And now we will actually execute it. So let's say we have const texts, and we just called text splitter, split document, and then we pass those docs that we console.log. And now let's also console.log those texts to see how that looks. Let's go again here, we send it. And now if we go here, we actually need to kill it and run it again. So let's go, sending, something is happening. Will it happen? It happened. And now you're seeing it's split. So you see you have document, you have page content, metadata. Document, page content, metadata. So you have those chunks and they overlap. As you can see, it says, I will continue building it in public, I will continue share, blah, blah. And here, I will continue building it in public, I will continue share. We want it to overlap. Okay, let's now continue. Before this step, what is actually really good, I realized it's simply a bit smarter, is to stick on that page content video title, because otherwise we will just put transcript inside, but then we won't have the title. So it's good to add the transcript too, and we do it by calling docs 0 page content, and we set it to video title is docs 0 metadata title, and then we set video content to docs 0 page content. This is not required, but I just realized that kind of like AI is smarter if you give video title to it too. Now let's add some metadata. So const docs with metadata. I mean, here we will basically just map our text and add a bit more data here. Nothing too crazy. So text.map text. So we return text, and then we need to add some metadata. We want to keep already existing metadata, and we want to add something really important, and that is document ID. I can put document ID here just to make it more clear, but basically in JavaScript, this is the same thing, right? And where are we getting the document ID? From the request. And as I've said, that document ID will be the ID of the video transcript itself. It will help us later and it's needed when we want to query something, because we need to know which video we want to query. Again, if you have thousands of videos and we just want to query this one, well, then we need to pass document ID from that one. And then when we, of course, store it, we need to save that, so that first we store it and later then when we query it, we know, oh, this is the ID we need to use. And finally, we will add those documents to the vector store. So we do await, vector store, add documents, and we add docs with metadata. But does it mean that this will really now work? Because after we call this, that should actually happen. We should store it in a vector database. Let's kill this. Let's clear it and run a new one. And now we don't want this. We want to send another request. Okay, something is happening, something is happening, something is happening. Will we see okay true or false? And okay is true. And if we go to our database, whoop, we will see this. So we have, well, the content itself, and we have some metadata, and then we have those embeddings. So those are embeddings. We cannot read them because, yeah, LLMs can read them and do stuff with them. For us, it doesn't mean a lot unless you're some alien here and you can read this stuff. And document ID is currently null because we haven't passed it in the request. But let's say we will just delete all this stuff. We don't need it. And now also here, we will pass our document URL, no, document ID, sorry. And we will set it to, I just took some random UUID. And I will send it, and something is happening, something is happening, something is happening. Come on. We go here, let's refresh. Cool, but document ID is still null. Why? Because the document ID needs to be auto-generated from the metadata that we're sending. Right now, if we look at here, we're not actually doing it, right? Document ID is null, but we need to auto-generate it from the metadata. To do that, let's go to our SQL editor. Let's do alter table, public, embedded documents. Let's alter our current column. So column is document ID. And now we want to auto-generate it from the metadata, as we said. So we will set generated always as metadata document ID. And we just need to cast it to UUID. We're also going to add stored in the end, which basically means that this value is physically in the database and it will update every time the value is updated. So if we run it, we have a problem. So let's just drop it. So drop column document ID. This is perfect. And now this should actually work, but we need to add a new one because we already deleted. So we don't need set, we need UUID. Perfect. So now we go to our table editor, embedded documents, and definition. We have perfection. Document ID, UUID generated, all this, blah, blah, blah. Let's see how will that work. If we again go here, store this document, and now this document ID is this 4D011. And now when we actually grab everything, and it is here, table editor, embedded documents, we refresh it, it's fresh, and it's here. Document ID is here. And as I said a few times, with that document ID, we will be actually grabbing this video. If you want to ask any questions, queries, prompts, whatever about this video, we'll need to also pass this document ID. Now I want to talk about LangChain. So document loaders, LangChain, let's say web loaders, to see how much stuff you have here. what we are using right now is YouTube transcripts loader, but you have like Puppeteer, Cheerio, Cascade, Spider, blah, 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 blah. You have so much stuff here, and you also have so much stuff here. Okay, let's say PDF loader. What you need to do, just install LangChain community, maybe some PDF parsing, blah, blah, blah. And then you again have this loader. So you see conster loader is new PDF loader, and you just do docs away.load. And that's how you would load a PDF. If we go to our code, which is here in the store document service, right now we're doing YouTube loader create from URL. This is our loader. And the only thing you need to do is you need to change this to PDF loader. And it works with so many other things. And as I said, this is your rack pipeline for storing the documents. Now you have it. If you want to add different things, then you will just in the request pass a type. Right now it's YouTube video, we don't pass a type because it's the only type, but later you will just pass a type, PDF, audio, YouTube video, whatever. And then here you switch it and you just get a different loader based on the type. And the same thing is with modals. Here we have the embedding modal, text embedding free large from OpenAI embeddings. If you want to use some different one, you will just pass a different embedding modal. Here you just create a new object, grab it from LangChain, pass it here, you can experiment with it. Super simple, super cool. Once you set it up, adding new stuff is super easy. Now is the time to build this absolutely amazing, gorgeous, pixel perfect client app for chatting with YouTube videos. And what we want to do, we said, we basically just want to drop a YouTube URL here and we want to store it. For that, we will of course call the already existing function that we've just implemented. Here's the project. It's basically just Vite and React. I created a new Vite project. I removed some of the boilerplate that they put there, and I just created this. So this is app.tsx. I added some CSS. What do we have? AI chat with YouTube, H1. We have the form, we have the input field, and we have the button. And that's exactly this. So AI chat with YouTube header, input field, button, this is a form. And when we submit that form, we call handle store document. Document. Let's just see and just console.log this URL here. If we put anything here, let's say this video, we drop it, we submit it, and it's just console.log here. And we already have some stuff, so I will just remove it here from the database to make everything clear. But now we need to do that processing. What happens when we pass the URL here? Of course, we store the document, but since we want to generate a conversation, we also have a couple of other things we want to do. First, okay, we need to generate some IDs for the conversation and the document itself, i.e. video. We need to generate that conversation, so that's chat. We need to generate the document and store it to the database. We need to link conversation and document. That's a joint table between conversation table and document table because it's many-to-many relation. Before, when I started, for example, I'm also, if you haven't seen, the founder of Second Brain, and chatting with YouTube was one of the first features. Initially, what I started doing is that I connected YouTube videos to every chat, which is good. You can add as many of them as you want to a certain chat, but then you cannot reuse them. And later, when I've added AI File Explorer, I decoupled that and I put documents as standalone and chats as standalone, so that you can easily, okay, you load the video and it's in the chat right now, but later if you want to use the same video for some other chat, you can easily drop it to the context because it's standalone. Because this storing of document, you see, it takes a couple of seconds. It's really not too long when you use Postgres, and it's pgvector. It's really not too long, I would say like 5-6 seconds, and it's stored. But of course it costs some money because OpenAI embedding models cost money. But then later, if you want to chat with that video again, if you want to create a new chat, drop new videos, if you've already done that processing, if they're already in a vector database, then it's first of all super fast, but second, of course, it's cheaper because you don't need to process those videos again. Okay, we don't need to log it. Let's start. Conversation ID is UID v4, const doc ID is again UUID v4. Cool, so now we want to generate a conversation, but we cannot actually generate it because we still haven't added the table to Supabase, right? Let's then just go here to Supabase. We need to add a new table, conversations. That will be our table with all the chats. So you process a YouTube video, you start a chat, and that's this. We really don't need a lot here. Just this we'll put to UUID, and we have created ad. Usually you could have some icons or titles or even user ID. That will definitely be added, but I simply didn't add it because I didn't want to have the entire logic for login and everything. Right now, at the moment, we just have ID and created ad. User ID, yes, definitely would be a great column. And then for the user, you can list all the conversations. Right now, we're gonna save it. And we need to generate the conversation. And to do so, first, well, we need Supabase. Supabase is create Supabase client. It's the same one that we had in our Node app. Literally, it's exactly the same. Let's maybe put it up here. Supabase makes it easy to do basic CRUD operations, like let's say insert. So you do Supabase from which table it is, conversations, and you just want to insert it. So you insert, and the ID is conversation ID. And now we can also, let's say we log it, console.log, conf ID is conf ID. And now let's see what happens. Okay, so this is the table. It's currently empty. And in our app, let's switch to network tab. So it's here. Let's submit it. And this is the conversation ID. Ignore this because I'm locally using different Supabases, so I get this warning. Just ignore it. And on conversations, we have post created 767. If we go here, refresh it, we can see 767 is here, which is awesome. Let's now dive back into our code. What do we want now? We want to generate the document. It's going to be exactly the same, but we will just insert it to documents, and of course we will pass document ID. Now we can also console.log this doc ID. But first, of course, we need to create a table. So it will go here. We will create a new table. It will be exactly the same. This usually would store things like titles and metadata and everything, but here it's really not needed for this simple app. And now, when we go here, we have it, documents, perfect. Let's go here, let's submit it again, conversation ID, document ID, conversation is created, documents is created, this is from before, that's why we have two calls. And we go here, we refresh it, cool, we have document, and we also have conversation. One thing I actually messed up. Right now, in Postgres, we have enabled our RLS. RLS is row level security, and it only allows us to insert, update, delete, or whatever data from the database if certain conditions meet. For example, if we would have user ID column here, then we can add a policy for this table that only user with that user ID, after it's authenticated of course, can update in this table, can insert to this table, can delete. So it's an amazing security feature, and we prevent other users from accessing and modifying other users' data. We right now have enabled RLS I will disable it. Again, just for this purpose, don't do this in production. I will disable it here. And there is one reason why this currently works, even though if RLS is enabled and we don't have any policies, then absolutely nothing should be able to be added here unless it's service role key, unless it's that hidden key. And because I just copy pasted code from our Node app, which is backend, and it's perfect, we can have it here, but we cannot have it on the client. So let's go to project settings, data API, and we will now actually add anon key here, which is public and it can be safely used in the browser. I just need to update it here in this super hidden file, and now we have anon key. And let me just demonstrate how would that work. So for example, right now it will work because RLS is off. But if I enable RLS for this table like it was before, and I go here and I try to create it, I will get an error, right? And it's gonna be new row violates row level security policy, which is perfect, but let's of course, for this purpose, disable RLS. Don't do this in production, it's fine for now. Usually you would probably have RLS based on, let's say, as I said, user ID. And now it should work again, perfect, both are created. Let's then, well, we'll actually delete the junk later. Now we need to link conversation and documents. It's John table in SQL, many-to-many relation. We can go here, we create a new table, conversation, documents. We have UID, and then we have document ID, again, ED, and then we have conversation ID, UID, it cannot be null. We now also need to add foreign keys. We go here, we want to reference conversations, and conversation ID from conversation documents needs to be ID from conversations. Here we can just cascade on every change, and then the same things we do for documents. So document ID from conversation documents, references ID from public documents, and we can just delete it on cascade. And perfect. This is our table now. Again, we will disable RLS so that we have free pass. And here we need to insert into conversation documents. What we will insert this time, conversation ID, of course the conv ID, and document ID to doc ID. And now if we are here, let's see what's happening. Conversations, documents, and conversations documents is created. So doc ID is 605, conversation ID is 27. And if we go here, conversation documents, we see conversation A27, doc ID 605. Is it good? Yes, perfect. So just to repeat what we have at the moment, on submit, we create conversation, we create a document, we connect conversation and document, and now finally we need to store the document. So let's do that. We do await, fetch, and normal people would put localhost here, but I just use ngrok for it, and I just want to call store document. We do send a couple of properties. Method is post. We need to send only one header, and that is content type, and that's application JSON. And finally, we need to pass those parameters, right? And we need to do JSON stringify and we pass URL and document ID, which is doc ID. And now this all should actually work. And let's see, here we will destroy everything, just so that we have a clean database with no junk inside. We delete this, we delete, okay, embedded documents, it's empty. And we have this YouTube URL, stuff is happening, conversations, documents, and our store documents function. This is the node service that we've implemented. Okay, we have some data here. Let's see, let's refresh it. Okay, cool. So now everything is here. Let's see, document ID 94D. If you look at it here, that's this one, 94D. If you go to documents, we'll see, oh cool, that's that document. If you go to chats, conversations, we go, okay, this is that ID. And now we have this table which joins document ID and conversation ID. And it's absolutely amazing because right now we have everything needed to start the conversation. But of course we still need to implement that whole logic for the conversation. This was now the first part where we store the document, and now we have actually the backend for it. Everything is in the database. We have our RAG pipeline for storing the document. We have this gorgeous, super nice client app. But now we actually need to query it, right? And okay, let's try to query this. We will want to summarize this video. Now that is our goal. So as before, first we will do our node service and we will test it there, and then later we will add it to the app. But our first goal is, let's do this node part, let's test it out with Postman, Echo API, whatever, and then we will do the UI for it. We are again in our service, and now similar to this, we just need a service for querying it. So query, document service, and of course route. We have query, document, route. So in query, we'll just remove a lot of this stuff, right? Because it's not needed. This will definitely be needed, so we'll keep it. Let's remove this. We also want to, in query documents routes, we want to call it query document, right? I think we can just do this good old way and change it to query. And of course, we need to add that route to app.ts. So we do it here, query. And here, we also want to change it to query. Will this now actually work? If we go here and we try to query the document, it doesn't really matter what we pass. Okay, yes, no, because we need to refresh it. So let's do here, we refreshed it, now it should be fine. Okay, let's see, it didn't start because of TypeScript error, of course. So we need to rename it here too. If we have query document service and we have function store document, so we obviously need to rename that to query document. This should resolve our TypeScript problem. Perfect, server is running. If we go here, okay, true, yes, now we have it. We have an empty function for querying stuff. Let's first write the steps. What do we need to do? We need to store users query. Second, we need to grab the conversation. Conversation history. Because as I said, LLMs are completely stateless. Every request is just completely new and doesn't have anything to do with the previous one. So if we want to achieve that nice conversation like you have in those sexy apps of today, we need to pass the conversation history too. Then we need to initialize embedding models and LLM models. Then we need to initialize the vector store. Again, the vector store where we will be grabbing documents from. Then we need to change the prompt based on the query and chat history. This is a bit tricky. So let's say you have a conversation about Eiffel Tower and you speak something about it and then you ask, when was it built? When was it built as a standalone question doesn't really mean a lot to LLM. When was it built what? So we need to change and adapt the prompt based on the history that when we actually later pass it to the LLM, it changes it to something like, when was the Eiffel Tower built? And that makes sense to the LLM. We then need to retrieve the documents, i.e. relevant parts from our YouTube video, and then we need to pass those relevant documents to the LLM. And finally, execute everything. Let me talk a bit about steps 6 and 7 because they are the most important. Based on the user query, of course, we change it and adapt it a bit to get better results from our vector database. But then, as I said, we have this massive storage base of our YouTube transcript. Based on the query and certain filtering, we grab only the parts that are needed, and that with the query, with the changed query, so that it also is aware of the chat history, we pass it to the LLM. And we can understand that better if we imagine a library. Let's say you go to the library and you ask for certain types of books. And librarian, they have a massive library behind and they're like, oh, okay. And they give you a couple of books. This is the step 6, retrieving the documents. Librarian understands you and gives you relevant books. But you don't know anything too much from those books. And then with those books and with your question, you go to a teacher and you ask the teacher. That is step 7. Those documents, those books that librarian gave you, with those books, you go to the teacher and say, explain me this. What is this? That's basically what we're doing here. We're retrieving relevant parts from our YouTube video, and then we ask the LLM with those retrieved parts to answer us the question. Okay, let's now go. We need to store the user's query. And for that, we need to generate the last table, and that is conversation messages. We will do that here. We have another table, conversation messages. Inside, we have conversation ID, which will of course be a foreign key to the conversation table. Then we have the actual content of the message, which will be text. And then we have the role. Again, text, it can also be like enum here, but let's just keep it as text. And role is user or assistant, because those are two main roles when you chat with LLMs. You are user and you ask a question, role is user, otherwise it's assistant. Perfect, we created it, we are creating it, adding 5 columns to conversation messages, it's created, perfect. Let's disable RLS. So here is our table. Let's now do it here. So we await Supabase from conversation messages. We insert conversation ID, and that obviously we will get from the URL. We can also remove these two for now. We have role, and that's user. It's hard-coded now. Don't hard-code it, make an enum. And we have content. That's query. Let's just put it here. Query, prompt, question, that's all the same, of course. Now, the conversation history. Const previous messages is Supabase from, again, conversation messages. This time we select everything, right? But of course we only want to select messages where conversation ID is conversation ID that we're passing from the request. Then we want to order it. So created at ascending false, meaning that the most recent messages will be first. And now we have a lot of stuff. What if it's a massive conversation history? Then if you pass the entire history, the context will again be too big, you will burn too much money and everything. There are like some optimization techniques you can do, but what really works well, although it's like really easy and dumb, is just limiting. So if we limit it to 14, that will be like last 14 messages, last 7 from user, last 7 from the AI, and it works actually really well in practice. So definitely for this tutorial is enough. Now a bit more boring stuff again. So embeddings, we need to initialize the embedding models, and that's again OpenAI embeddings. I mean, it's basically the same one as in store document service, so we can just copy paste this one. Cool. We just need to import OpenAI API key, and we also need to initialize LLM. For that we need to also import chat OpenAI, and that's going to be new chat OpenAI. Model is going to be GPT 4o. You can also use 4o mini. It's actually really good and cheap, but let's go with 4o now. We'll do API key, and let's set it to OpenAI API key. And finally, we will stream usage. Let's set it to true. What is streaming? You know, when you prompt an LLM and then you don't wait for the entire message to arrive at once, but it's coming part by part, that's streaming. Now we need to initialize the vector store. It is basically the same as here. The only difference is that we have a filter. Filter will be document IDs, and we will pass document IDs that will of course come from the request. And with this filter document IDs, we know exactly which YouTube videos do we want to speak with. And now is the time to implement this match documents function. So here is that function, and based on that function, we will grab relevant documents from our vector database. We need to pass our embedding. We put 3072 because that's the vector dimension, because text embedding free large is 3072. Then match count, integer default is 5. We can change it if you want 10, for example, to have like bigger match. And then the filter. In our filter, we of course have only document IDs, but later you can also pass user IDs, and then you can also create indexes based on document ID and user ID, and then make everything faster. We will return ID from the document, its content, text, metadata, and of course, similarity. This is our array of documents. Here we're just doing some initial logic. If something is null, then we raise exceptions. If something doesn't exist, we raise exceptions. And here we are grabbing those documents from the past documents IDs that we want to filter. And now what we do, well, we select ID, content, metadata, we calculate similarity, and we return it. This is our matching function. This function will grab documents from the vector database. And what you need to do to actually use it, you need to copy paste it. Then you need to go to SQL editor in Supabase and paste and run the function here. We can now return to our query document service and continue. Now we need to change that prompt, and I will just paste it here and then explain it. Okay, here we have a couple of things. We need to import. Let's go here. And we need to import chat prompt template and message placeholder, of course, from LangChain core prompts. Let's go here. And this is that prompt that we were speaking about. Given a chat history and the latest user question, which might reference context in the chat history, formulate a standalone question which can be understood without the chat history. Do not answer the question, just reformulate it if needed and otherwise return it as is. We have this system prompt, we have chat history, and we have new user's prompt. This is kind of like just like a set of instructions of how to rewrite that question. And now we can actually retrieve the documents based on this changed prompt. Retrieve, this is a small typo. We will first generate a retriever. This is basically just the function that grabs the documents based on vector store retriever as retriever. Yup. So based on the config that we have here, this is our function that searches for documents. And you can look at all these as just like set of instructions, like how to change the prompt. But now we will actually execute that with create history aware retriever. That's again also from LangChain. LangChain chains history aware retriever. And here we will do const history aware retriever is create history aware retriever. Okay, I see a typo here. I want to fix it. Create history aware retriever. We need to pass LLM that will be actually changing the prompt. Retriever that will grab the relevant documents for us, and this prompt so that we change the user question based on the prompt and of course the chat history that we passed before, and this is contextualize Q prompt. And now when we have those retrieved documents, we want to pass them to the LLM. Again, this is the step with the librarian. So we ask them, hey, I'm interested in this. And then librarian gives us a couple of books about the topic. That's step 6. We have those books now, and now we need to pass it to the teacher and ask the teacher a question, specific question that is in those books. And we will get the answer. So we have a new system prompt. You are an assistant for question answering tasks. Use the following pieces of retrieved context to answer the question. The first system prompt was for changing the user query and grabbing the relevant documents stored in our vector database based on the user's query. And now when we actually have them, we're making another call to the LLM, and here we also pass the documents that we grabbed, that our retriever grabbed. Again, we define how everything will look. So we have a system prompt, we have chat history, we have input, and now we will use create stuff documents chain, which combine all the documents that we got in a single context. And then alongside with the query asks the LLM that final question, and then we get the response that we see. So let's generate the question answer chain, and that is await create stuff documents chain. We need to pass the LLM and we need to pass our prompt. Now is the time to execute that final chain, that retrieval chain. So let's do const rag chain is await create retrieval chain. And what do we need here? We need our question answer chain and we need our history aware retriever. As I said, 2 stages. Before, we were mostly just setting the instructions. How will everything run? How will everything be changed, contextualized? How will everything be fetched? Based on what? We were setting all the instructions, and now we're gluing all of that together. So retriever, history aware retriever, and combine docs chain is question answer chain. And okay, we have this TypeScript error, which basically says that we did not await it. So if we await it, the error should be gone. Now let's again grab our history for our final execution. So we have human message and AI message. We're importing it from LangChain core messages. Let's come here and do const history. That's previous messages. We're mapping them. So we have a message. If message and its role is user, then we generate new human message content, and otherwise new AI message, again with message content. And we have these TypeScript errors here. So let's see what's here. What's the problem? Yeah, so Supabase will return data as previous messages, and that should be better. Yes, perfect. And message implicitly has any type. Well, then we will explicitly set any type. My bad, so this is actually the final step, and the finals of the final is const response is LangChain stream. What do we put here? Input, that's the query, and then chat history is history. My bad, this should be out, obviously, we don't want to map it. But wait, now it seems like we have some TypeScript error here. Oh wait, again. Previous messages is possibly null. Well, then do this. Now it's better. This void. I think we need to return it here. Okay, yes, so now this is mapped and everything, and now we have this response. But since this is streaming, we cannot just return it, right? So what we have to do is basically to have this readable stream. And this is just a classic way of how LLMs work, not just LLMs, but streaming in general. And for the response, I think we also need to await it. That's why we have this error. Perfection. And now here we can also console.log this, just to see what's happening. Will we actually get the answer now? So this is just like chunk of the answer, you know, like when it streams, then it goes bit by bit. Let's see if we will actually see something here. If not, well, we need to debug something. Okay, let's go to, here. And what are we passing now? Let's go back to our function. We have conversation ID, query, and document IDs. If you remember, we already did that when we were storing the document. So we will grab our data from there. Conversations, we already have conversation ID. Let's come here, conversation ID. Let's set it to this. Then let's do document IDs. And in this case, that's this one, right? Let's do it here, document IDs. Wow. Document IDs, an array. And finally, we have our query. summarize me the video. Now let's see what will actually happen. Okay, we got some readable thing back, and we have absolutely nothing. And that is actually because, remember when we were setting the routes here in store document routes, and we had this, we just awaited the result and returned it like JSON, like this. Here we did the same thing, but the thing is that store document, it's a regular request, but this is a readable stream. So we cannot do it like this. We need to do it differently. How do we need to do it? We need to set a couple of headers. Response, set, header. What do we need to set? Content type to text event stream, right? Not application.js/js. Then we want to set response, set header, cache control, no cache. And finally, we want to set header, connection, keep alive. My bad, we have this here, and we don't want to do this, but we want to result pipe res. Okay, TypeScript is screaming. Okay, because of this OK boolean. I guess here in query document, this was just for testing. Anyway, we can simply throw this error and this will be removed. And now it doesn't scream anymore. So let's restart it. Let's do it here and let's send our request. Okay, stuff is probably happening because it takes a long time. It takes a long time and that's it. Look at this. So we have those pieces. Obviously they're not streamed here, but we have the video is an honest review of Supabase based on the experience of a former front-end engineer. And if you go here, that's also here. So, I mean, we actually have it now. We just need to implement it in our React app, but we have it here. And now let's actually do the entire flow, but with another video. So what do we have here? Our app is dead, so we need to run it. Perfect. Now we will store something. This is another video from Kurzgesagt. Let's do it here. We have blah blah document, store document. It's being stored. That, as I said, takes a couple of seconds. And we have this document ID. It's all stored now. And now based on this document ID, we want to get a summary of this video. And if we go here, the only thing we need to change is this. Actually, the conversation ID too. And if we run this query, we should get a different summary if it works well. Because this is already stored and everything. Okay. The video discusses how the brain constructs our perception of reality, revealing that we are not experiencing the present moment as we believe. Instead, our brain creates a story that feels real by processing memories and editing visual information. Oh, this sounds like coding. But yeah, you see that we actually have it now. We have storing documents, we have retrieving documents, so the only thing we need to do now is put it into our React app to make everything nice. So this is our React app. We are handling this store document here like this. You should obviously extract these to like different helper functions or something, but let's just keep it here for the purpose of simplicity. We want to set this document ID and conversation ID. So we're setting conversation ID set conversation, use state, it is, well, it's undefined. But then we can set it after everything is done. We set conversation ID to conv ID. Okay, so it's screaming again. We're just gonna do it like this. And we also need to set document IDs. We're gonna set it to doc ID. And here we have document IDs, set document IDs. It's just an empty array. And it's screaming here. I think we just need to set string here, and then TypeScript will stop screaming. And that's basically after we generated all these objects, after we stored the document. You can see that there is also a lot of potential here for making it faster, but by not awaiting everything, but just do promise.all. And now when we have stuff, what we want to do is this. After we've done and we have a conversation ID, that means that we have chat interface. Usually, of course, you would have React router, you would just put that to a different route. Here, it does not really matter. So if we have conversation ID, then we will just return chat with YouTube. We will return, well, which YouTube URL that is. We will show previous messages, which we still need to implement. We have another input where we are setting the prompt and the button. This is the old thing. So this is displayed first. It's AI chat with YouTube. Here we paste the YouTube URL, and this part, it's when it's pasted and processed. Then we have the conversation ID, and now we can actually chat with the video. So what do we need? We need messages, right? We need to messages, set messages, and it's use state, and that is this message object that we have above. This, you see it? So role is user or assistant, and content is just string. What else do we miss? Handle send prompt. Well, that's obviously extraordinarily important. We need value. Value is basically like URL, but instead of URL, we will have prompt and set prompt because it's just another input field. And we need is streaming. We can just call it streaming to be consistent. Here we set streaming, streaming, streaming. And then of course, the main thing is handle send prompt. It's of course async. This, and we just console.log prompt for the start. But also, let's just prevent default, right? This should be React form event perfection. And now, when we go to our app, when we submit it, stuff is happening, awesome. We should be in that new state pretty soon, and when we type summarize and send it, we just see summarize here. But now, what we need to do, we need to call our query document function that we've implemented, and we need to show the streaming here. Let's first generate user message, which is type of message. And let's set content to prompt, right? And role to user. Perfect. And then we want to immediately render it. So we'll do set messages. Let's do prev and prev user message. Perfect. Now when we actually ask a prompt, we will see it on the UI, but we also need to prepare the assistant message. So we're gonna do this. Content will be just empty string, and role will be assistant. We of course need to set it to, let's copy this, paste, assistant message. And now the fun part starts. We have this function for storing the document. Let's just generate a function query document, which is of course async, and we pass query, that's a string. We pass conversation ID, that's string 2, and we also pass document IDs, which is also string. We will do this, but we will just change this to query, right? And here we can pass query, we can pass actually document IDs, and we can also pass conversation ID. Perfect. We just then need to obviously get a response here and just return that response. Perfect, perfect, perfect. Let's then, so we're handling the same send prompt. Let's try const response is query document. What do we pass? We pass the query. Where is it? Prompt. Okay, great naming. We pass conversation ID, and we also pass document IDs. Now we get a reader. Response, body, get reader. Oh, so not like this, but I wanted to await it here. Here is screening, argument of type screen. Okay, yeah, of course. I need to do it here. And then, let's of course, just to remove this error, we catch error and we just console.error it. Let's go back here. Now we need a decoder, which is a new text decoder. By the way, what I'm doing right here now, it's just general client-side streaming. It's nothing specifically related to RAG or anything, it's just receiving readable stream. And because of that, let's then just paste the code for it. Reader is screaming, so if there's no reader, we should probably throw an error, right? Or just return. Huh. We actually need to call this function, of course. And what do we do here? As I said, it's kind of like common practice to do when getting a readable stream. So we have a while loop, and until it's done, we are decoding chunk by chunk. If line starts with data, that is our data, because you can see it here as we executed it, data, and then we remove these first 6 characters, and then that's exactly what we want. Content, visual, content, information, content dot, content it. We basically want to grab this content from here, and immediately as we grab it, we want to add it to the UI. And that's what we were doing here, right? If there is data content, we grab this and add it to full content just to get the full response from the assistant, and then we're setting messages. And we're always setting the content of the last message to full content, and this full content is constantly incrementing, and that's basically how we get that stream. Always a bit is added and added and added, and that's how we get the stream. And then the final thing we need to do after all of this is done, so well done, then we have that full content, and then we just need to store it. So we do Supabase, this Supabase create client, it can also be here. Let's put it so that we can access it. Supabase from conversation messages. We need to insert this last message. We're doing conversation ID, and that's conversation ID. Role is assistant, and we have content, which is full content. And now, if we go to this AI chat and we drop the video, magic is happening, we're storing it, and this, I think, will actually work now. Okay, we're chatting with the YouTube video. That's like my video about Supabase. Summarize the video in numbered bullet points. And perfect, we have it. We have numbered bullet points. But now, just to like prove that also the conversation history is working, let's, for example, say, tell me more about one, which is a standalone, it doesn't mean a lot. But we asked, tell me more about one, and we see it's connected to this. As I said, it's not the most beautiful front-end app, but it serves the purpose. Thank you so much for watching this. Right now, we covered everything. We covered storing of the document, we covered generating conversations, connecting those documents to the conversation and having an actual chat with the file. Some possible improvements would be, I would definitely deploy this. Frontend can be deployed to Vercel. You can deploy this node app, I love fly.io. It's just like really super simple to deploy there. Supabase is already live anyway. You of course need to update the UI and everything. You can add better indexing. You can add tons more file support to your pipeline. But as I said, you now have everything. So adding a new file sometimes will be literally on your backend almost nothing. It will be more work on the UI to make it work, but you now have that pipeline and that chain in LangChain, so it works awesome. And there are also some more performance improvements you can do. You of course need to implement login here, user authentication and everything, but this is the skeleton for it. And yeah, it's simply crazy because right now in this thing you can drop any YouTube URL and have a conversation with it, which is pretty crazy. Thank you so much for watching the video. Like, subscribe, share if you like it, and see you in the next one. Cheers!